We are now in section 3.3, and we do have, or this particular section deals with properties of functions. And specifically what we're going to be looking at in this particular section are what are called even and odd functions. And we're going to need to figure out what do they look like as far as graphs are concerned, or how can we tell if we're given the equation whether or not they're odd or even. We're also going to be looking at increasing functions, decreasing functions, and constant functions. And then we're going to look at how can we find maximum, minima, and what is called the average rate of change. And then we will end with what is called the difference quotient. So we've got quite a bit of things going on here, but none of them are particularly difficult. It's just learning a set of rules to go with here. So we look at example number 1, and the first thing it asks is decide whether this graph is either even, odd, or neither. And the things that you need to realize is that whenever we have a graph of a function, then if it has y-axis symmetry, if it's y-axis symmetry, then that means it is even. It is an even function. And if it has origin symmetry, then we have what is called odd. It is an odd function. And so that's what we're looking at here in this first group. So number 1, we look, does it have y-axis symmetry? In other words, can we fold it left over right and it lay on top of itself? The answer is no. Likewise with the origin, well, it has the point 0, 1, which means 0, negative 1 should be another point on there. And so no, there is no origin symmetry either. So since there's no symmetry, then that means that it is neither odd nor even. Okay, number 2. We ask, is it y-axis symmetry? Can we fold left over right? If we do, it will not fold on top of itself. However, when we look at origin, it does have origin symmetry. Which means it is an odd function. So there we can answer number 2. Now, how do we determine these things if we are given equations like 3 through 5? Well, the first thing we do is we have to find f of negative x. Basically, if f of negative x is exactly the same as f of x, then it is even. If, however, f of negative x is the opposite of f of x, then it's odd. And if neither one of these two situations occurs, then it's neither. So first thing we have to do is we have to find f of negative x. So number 3, f of negative x equals negative 5 times negative x squared minus 4, which equals negative 5 times x squared minus 4, which equals negative 5x squared minus 4. And then I look at, well, how does that compare to the original function? Well, the original function is negative 5x squared minus 4. So it's the original equation, which means it is even. Example number 4. We need to find what is f of negative x. Well, that would be the cubed root of 7 times negative x squared plus 4, which equals the cubed root of 7x squared plus 4. And then I compare that to the original. Well, the cube root of 7x squared plus 4 is exactly the original, and so that would mean it is an even function. Example number 5, we need to find what is f of negative x. So that would be negative 5 times negative x all over the absolute value of negative x. Well, negative 5 times negative x is 5x. And this becomes the absolute value of x. And now we can compare this to, okay, how does this compare to the original? Well, the original was negative 5x over absolute value of x, which works exact opposite. The only thing that we have to do is to negate this whole thing. So that means this would equal the opposite of f of x. Since it's every sign has changed, then we know that it is an odd function. Now, the next group of problems, we're given graphs once again, and we need to determine whether it's increasing, decreasing, or constant, and they'll give us a particular interval. Now, the easy way is if it's going uphill when you go from left to right. Going from left to right, if it's going uphill, it's increasing. If it's going downhill, it's decreasing. And if it's staying constant, it is constant. And so we are asked in number 6 between 0 and 1. Well, if we look from 0 to 1, that's from here to here. When x is 0 to 1, it's going downhill the whole entire way. And so this would be a decreasing function. Example number 7. We're going from 1 to infinity. Now that's when we're talking x. Well, from 1 to infinity, 1 starts here, and then it just keeps on going this way forever and ever and ever. So this one is also decreasing. And finally in this group, number 8, we're going from negative 1 to 0. Okay, at negative 1, it appears to be about right here, and 0, it appears to be right here. So it's just this little stretch that all we're concerned about, and this seems to be going straight across. So this is a constant interval, or the function is being constant over that interval. Now number 9 asks us to look at the graph and to find what intervals it's increasing, decreasing, or constant. Now it's very important, one thing you need to understand about increasing, decreasing, and constant functions, they are never closed intervals. In other words, they will never have brackets. They will only have parentheses. If you have brackets, you can guarantee it will be wrong, because right at where it turns, it's neither increasing or decreasing or constant. It's none of those, and so you cannot say right at that point there's nothing going on. So number 9, it asks where is it increasing, decreasing, and constant. So it will be increasing any place it's going up from left to right. Well, that appears to be occurring from negative pi over 2 all the way until pi over 2. Now it doesn't include the exact spot at negative pi over 2, because at negative pi over 2, 0, it's doing nothing. It's not increasing, it's not decreasing, it's not constant. And likewise, it goes until pi over 2. So that's where it's increasing. It's going uphill. But where is it going downhill from left to right? In other words, where is it decreasing? Well, it's at negative pi until negative pi over 2. It seems to be going downhill. And once again, right at negative pi, we can't tell exactly what it's doing because it doesn't have anything on the other side. It could immediately turn constant at that point. But it also is decreasing from pi over 2 to pi. And notice, once again, nowhere do we have brackets, but we do have unions. In other words, not only are we talking that it's decreasing here, but it's also decreasing during this interval as well. Now, by the way, that was example number 9, and I apologize for it being in a very strange spot. And so let's look at number 10. Example number 10, the graph of the function is given and use the graph to answer the question. And we are asked, find the numbers, if any, at which f has a local maximum. And what are the local maximum? And this is where you need to be very careful with the way the wording is. It asks, does it have any local maximum? And where does that occur? Find the numbers at which, or in other words, find the numbers where f has a local maximum. And then what are the local maximum? Two different questions, two different answers, potentially at least. Where, when it asks where, you're asking what are the x values. And when you're asking what are those local maximum or minimum, you are asking what are the y values. So to answer the question, find the numbers where f has a local maximum. Well, we look, where does it end up being way up high? But it doesn't necessarily have to be at the absolute highest. There can be maximum that aren't as high, but that's why they're called local maximum, because within a certain range they are the highest point there. And so if we look, number 10, we have a high point at negative pi, and we have another high point at pi, both negative pi and pi. So we can say at negative pi and pi we have maximum. Now the question is, what are those maxima? Well, the maximum, when negative pi, it seems to have a y value of 2. And when we look at the graph where pi, when x equals pi, the y value appears to be 2. So the maxima are 2 and 2. And realize it is very possible that these maxima will have two totally different answers, or two totally different values.